Welcome back to the hyperbolic squadulence producing chamber. We are back once again for another LeetCode, another dive into the abyss. The abyss representing the large carcass or corpse of bodies that the bodies of work that the LeetCode developers have created. And we are simply, there's got to be some prominent archaeologists or miners who found some pretty cool things by hitting rocks with heavy things. We would be one of those people, but who knows? That being said, I have an announcement. We lost. I have to give the Zuckster his props. I gotta give Susan the props. I gotta give the owner of ByteDance / TikTok their props. These companies have banded together to create not one, not two, but three, but darn near six Zonk machine assembly lines. So it's pretty much impossible to escape. I used to use Pinterest. I still use Pinterest to gather some supplies to draw, for just pretty much references to draw. But it has also become an application which is impossible to escape. Each app feels like actually, I have a good example for this. No, maybe not. Either way, we're just going to make one up. A lot of these apps feel like a poisoning embrace. You're feeling the warm, nice candle-like intensity of emotion as the serotonin and dopamine flushes through your PFC and into the base of your cerebellum. You feel a nice, cool, calm breeze as the never-ending screech of society moves to a halt. You feel a moment of bliss. Silence. Unfortunately, this embrace is also why we hear the screech. And I gotta give it to these people. They have created not one, not two, but not even three, not even four. It's impossible to escape. I think every modern platform now has some sort of shorts like thing built into it, and it's at this point it's impossible to escape. I mean, even now when I open up YouTube to check my subscription feed, I get automatically pipelined into shorts. Before you know it, you're scrolling a couple of videos and you're like, let me see, this video is upsetting, let me read the comments. The comments also have you hyper focusing. Before you know it, you're 15 minutes in deep and you don't even know why you opened the app. Pinterest is also like that. I'll go on there for some art references. 15 minutes later, it's game over. I think the strange part is that it's just a strange thing. The better we try to make something, the harder it is for us to stop using it. So who knows at this point? Maybe I don't know enough about behavioral psychology or sociology or any of these other stuff, or even people, to know whether or not these apps are just making something better, or these apps are doing something that's like, you go to your friend's house, you have a friend, their job is, if they're inviting you over, they're a host, their job is to make sure that you feel, welcomed, that you can come over, that you can have fun, you can relax, you can have a good time, right? But these apps, on the other hand, feel like the friend whose house you go over to is also warm and welcoming and inviting, who refuses to let you leave. And it's kind of like the friend who's like, I'm about to head out. And you're like, you just showed up for a little bit and now you're leaving. That's kind of strange. Now you feel like you have to stay. But who knows at this point? I'm just rambling like a madman into the content pipeline void. But that is to say, I got to give these people their props. Somehow, even YouTube Shorts' algorithm is rivaling that of ByteDance's soon. It's hard. TikTok pretty much has the gold standard of this algorithm. So I'm sure the big brains at YouTube are shelling out massive checks to figure out how they can do the same thing. But YouTube already has a large user base, so maybe they have more data. Hard to know. All I'm trying to say is the pipelines have sucked us in. Fortunately, not for too long. But yeah, things to be done. Now there's even less time to do them. So I think that's fine though. Sometimes you got to do what you can. So I don't want to have a defeatist mentality. I don't think we're going to do an hour today, although I would like to. If we do an hour today, it's going to be 12. I still have to work out and eat and make food. And then I still have to do some actual work from work that I didn't finish. Or should be done. It's not done yet, so it's kind of on me. So, balancing priorities, another box to tick. That is to say, who knows? At some point in the future, I don't know. I don't know if it's maybe just my brain chemistry that's garbage. Maybe other people have no problem saying no to these things. But yeah, I'm not certain. It seems impossible to escape. Either way, LeetCode feels like its own form of medicine. Not because LeetCode is special, but I think more because the act of sitting down to focus on one thing for a set amount of time every single day is definitely strengthening discipline or ability to corral attention. So that's useful. It's definitely made a lot of other things less difficult. But unfortunately, it's an interesting tug of war. The better I get at LeetCode, even though we're not that good, but we've made progress. I would be lying if I didn't think we were better than we were 100 days ago. I think we definitely are. But it's definitely an interesting tug of war, since the better I get at LeetCode, the more I enjoy it as more of a way to just enjoyment, right? Working on the problems, having a space for boundless thinking. But the more I enjoy it, the less it actually works as a pretty much a technique to corral attention. Let me say that more succinctly, or let me just try and make it make sense. What I'm trying to say is the more I enjoy LeetCode, the less of an effect it has outside of me practicing it, because part of the reason I'm doing this is to train focus, and the more I enjoy LeetCode, the less it is about actually training focus, and the more it is about me just doing something that I enjoy. So, fortunately, nothing lasts forever, and fortunately, neither does enjoyment. So there will eventually be a stint where we're no longer enjoying LeetCode again, and now it's work. And I think that's when we get the benefits of focus. So, who knows? At this point, we're just talking nonsense. I don't think we have any comments. I peeked earlier. Sometimes I peek throughout the day to see if we have any comments. We had one earlier. I already laughed at it. I already read it, and it was pretty wild, but we don't have any new comments, so we're not going to do a long session today. Part of me wants to just do a new problem completely instead of for some. I refuse to check the solution. I refuse to check the solution. I refuse to check the solution, and we're going dark mode. Maybe we should check the solution. You know what I think we actually need? I think we need, you know what I'm going to do instead? Now, I think we're just going to continue with the problem. We're marking more spots in the maze, but I also feel kind of nutty for doing 20 minutes because it feels like by the time we'd get to the... Besides the point, I think we're just going to jump into it and see what we have to gain from this. We're going in dark mode, though, because my eyes be tired, though. And I think we're just going to jump into it. So we're going to do 20 minutes, nothing crazy. And we're just going to see how it goes. So you got a 20-minute bonger. Oh, wait, this is threesome closest. Yeah. I don't know how we got there. What we were working on right now is we sorted the input list, right? And now we're doing consecutive binary searches. The problem is, and we should have known this from the start, this solution is not exhaustive. So either our approach is completely nonsensical. Consecutive binary searches, there's no way consecutive binary searches gives us an exhaustive account of all combinations of numbers. Or the way we're currently writing this code does not, or the way we're currently writing the code does not allow, the way we're currently writing the code does not allow for any sort of extensibility in regards to, or maybe we can get an exhaustive version of this with consecutive binary searches, but the way we've written the binary search, or maybe the overlaying mechanism, is not worthy. I don't really know how else to put it. Either way, we're not making any progress. Something's got to give. What we tried to do here is we tried to do consecutive binary searches, right? And for the number that we find, for the third number, we'll splice it out of the array. We also splice out J from the array as well, which for some reason seems to be gone. Oh yeah, we deleted it. That doesn't work long term. So how do we make sense of this? Splicing and dicing. Consecutive binary searches Is there a way to make consecutive binary searches make sense long term? It's not exhaustive. It doesn't make any sense. I also just realized it's not exhaustive. I don't think consecutive binary searches is exhaustive. One, I don't think with the binary search it works that we can filter out elements. The reason I don't think that works is because we need a unique we need a unique set of quadruplets. One of the ways we know it's a unique set of quadruplets hold up. Maybe this actually can work. What if instead of returning the index from the array, we actually return the number at the index itself, or the number at the index itself? This makes us not have to worry about sliding indices up and down. Similarly, since we spliced the elements out of the array, after we found them, we can assure that each A, B, C, and D are distinct indices. If we splice I and J out, First, we need to get this back to a state where it runs normally. And now I'm realizing we already had a version of this that ran that made sense. I'm pretty sure we should just go back to it. Here we had a triple binary search. Here we got TLE. If we look at wrong answer here, this is a version with consecutive binary searches. That did not get us what we were looking for. I think if we go back here, paste this, we should see that it runs and we get the wrong answer. Right. We get the wrong answer because it wasn't exhaustive. Now, if we do what we did before, right, instead of binary search returning an individual index, it would return the actual number. And then we could change this from K to KNum, and then M to MNum. Instead of doing sum plus that, we'll do sum plus KNum. And then instead of doing sum plus equal num sub M, we can do sum plus equal MNum. Here we don't have to make sure the indexes are distinct. You can say distinctness provided by R splicing. We don't have to do the sorting because that was also about the distinctness. All we should have to do though we can say chosen nums be equal to num sub I, num sub j, mnum, as well as knum, and then we can do chosen nums dot sort call this nums ID. We don't have to do the thing about checking if the size is equal to 4. And then we can do answer dot push chosen nums. I think so far they should keep the test cases passing the same. Oh, right. It's failing right because we haven't done the part that guarantees a distinctness of indices chosen. To do that, if we're going to return the number post splice, you could use a temp array. This is because after the binary search, we won't exactly know. So we'll say const temp is equal to nums, and then our B search is actually going to modify this array. Right, if we return nums sub pivot, we're first going to do equals nums sub pivot, right? And then we're going to do is return temp, and then additionally we're going to do nums dot splice pivot and delete that one number. We're going to copy this block and do the same thing down here, except temp is going to be equal to nums sub left. It's going to modify the array by reference, and I think this should I just realized we're not splicing out I and J. Right. So -2 and -1. If we look at the pre-search, looking for the closest thing to 3, and we found 2. We can see that 2 is gone, and then we take 1. You see we have -1, 0. So if we take a look, we have an extra one here for some reason. We have -2, 0, 1, 1. It's not possible because there's only 1, 1. I think it's because of how we're splicing I and J here. And I think we need that block we removed. If I is less than J, we would splice J at its current index. Otherwise, if I was greater than J, then the removal of I would have put J one index before where it should be. Or maybe not at all. So we see this a couple of times. I is negative 2 and 1. If I is negative 2 and 1, why do we have a 1 still available here? So we have negative 2 and 1. And I think that's what we see, like what we said before. With negative 2 and 1, right here, we can see that negative 2 and 1, but 1 is still in the array. How is that possible? We print j using num sub j, which would be its correct index. Problem being, we never actually spliced anything of value out. I think we need 2 of these. Actually, no, so if we always splice I out first, it'll never be affected. And in fact, it should be the opposite. If I was less than j, then we should do j minus 1. Otherwise, okay. So now we have 3 passing. If we comment out, yeah, it's still not exhaustive. But this submission is already saved. If we go to our last TLE version, this was the version in n cubed time using the binary search that gave us TLE. Actually, this wouldn't be much better now that I'm thinking about it. N squared takes too long. Not exhaustive, right? But also waste of time. I don't know why I keep trying this approach. Maybe it can be made exhaustive. We're filtering out the numbers we've already chosen, and additionally, to be honest, it doesn't even matter that this array is sorted. We're not even using that fact. In fact, I'd be curious to see if the n cubed version worked if we remove the sort at the top. I mean, we have no hope. So we might as well try this version with the B sort, with the B search, and just remove. You might as well try it and just see if we remove the sort, if it works. Because you don't need the sort for this to work. Actually, you do need the sort for this to work because it's the binary search requires a sorted. Okay. Wait, how did they get -3,223? wait. Oh, wait. No, maybe I read that wrong. It's -3, -2, 3. But unfortunately, when we go down the -3 route, we always end up doing -3, -2. And if we choose 1, we've already chosen that one before. Yeah, I guess this doesn't make much sense. B search is not exhaustive. Could we use it to be more exhaustive? Maybe we could. We would just choose the next closest number. How do we know when to stop? Yeah, I think we'll just stop there for today.